here is a problem on the first law. It says the following table gives data in kilojoules for a system undergoing a thermodynamic cycle. We are asked to determine the missing table entries and whether the cycle is power producing or absorbing. So, there is some cycle which consists of 4 processes. So, we are given each of those processes. So, for example, let us say it has some 4 processes, 1, 2, 4, something like this. For 1 to 2, change in internal energy is given, not given, Q is not given, but W is given. Okay. So, what we see is W is negative. So, the volume must be reducing. So, 1 to 2, the volume is reducing. So, and the remaining are also given like that. So, 2 to 3, volume is volume must be increasing because work is positive. 3 to 4, work is again positive. 4 to 1, work is 0. So, this is not a correct schematic, it is just like 4 points here. I have not drawn this taking into account these at all. But what we know is it is a cycle. So, if it is a cycle, what we know is that the cyclic integral of del Q should be equal to cyclic integral of del W, which is essentially the first law in its original form. So, if I have discrete processes like this, I can also write this. And what we also know is that for a cyclic process, properties do not change. So, for a cyclic process, if I do this, I would get 0. Properties do not change, which is true, because if I do delta U is U2 minus U1 plus U3 minus U2 plus U4 minus U3 plus U1 minus U4. If I add all of them, I would get 0. So, what I know is this summation, if I sum all of this, this is 0. This need not be 0, this need not be 0. That is something I know. But what I know is if I sum up this, it has to be equal to this. So, this I know all the values. So, let me sum that up first. So, if I take sigma of these values, I have minus 610 plus 230 plus 920, which gives me a value of plus 540. Cyclic integral of del Q should be equal to cyclic integral of del W. So, this also must be 540. That is known. This must be 0. That is also known. Now, for each process, if I look horizontally, this is one process. For each process, I have the first law as dE is del Q minus del W. So, that must hold for each process horizontally when I take. So, for example, here I know 2 things. So, I have del U. So, looks like there is no other energy. So, I can also write this as du, or in integrated form I can write delta U is Q minus W. So, delta U should be Q minus W. So, I can find out the value of Q. So, Q is essentially delta U plus W. So, Q must be delta U plus W. So, that is 670 plus 230, which is 900. Similarly, for this process, this should hold. Delta U is Q minus W. Delta U is Q minus W. So, Q is 0, W is 920. So, this must be minus 920. So, now I know that the sum of this should be 0. So, so this value delta U for 1 to 2 plus this minus this should be 0. So, delta U plus 670 minus 920 minus 360 should be 0, which gives me this delta U as plus 610. Now, I can apply this for this row here. So, delta U should be Q minus W, delta U should be Q minus W. So, Q is essentially delta U plus W, delta U plus this value, which means this is 0. And now I can sum up these two and look at it. I can't, can I do that? Yes. So the sum of this 0 plus 900 plus 0 plus q from 4 to 1 should be 540. So q 4 to 1 plus 900 should be 540. So q4 1 is essentially 540 minus 900, which is minus 360. I could have also got this by looking at this formula for this, and I can now check if it's consistent. Delta U should be Q minus W. So minus 360 I have here. Q minus W is also minus 360. So this also is fine. So I could do this again in multiple ways, but doesn't matter which way I do, I get all of them as the same. So now I have the values as 610, 670 minus 920 minus 360, 0, 900, 0 minus 360, minus 610, 230, 920 and 0. So the question was find out the missing table entries which I have found, find out whether the cycle is power producing or power absorbing. So in order to look at whether it's power producing or power absorbing, I need to look at W. So the summation of W values is 540, which is positive. So this cycle gives positive work. So therefore it is a power producing cycle. So because this value is positive, I can have this as power producing. So essentially I have a power producing cycle which gives out 640 kilojoules of work. What we also see is that it takes in, gives out 540 kilojoules of work. What we also see is that it takes in 540 kilojoules of heat. Heat transferred to the system is positive, work done by the system is positive. So there is heat transferred to the system and it gives out work. There is no change in internal energy because it's a cyclic process. The system comes back to its original state after doing work.